Hello busy people, welcome back to my channel Leetcode for you. Today I am going to solve daily Leetcode challenge linked list in binary tree. The question states that given a binary tree, root and a linked list with head as the first node, our task is to return true if all the elements in the linked list standing from head corresponding to some downward path connected in the binary tree, otherwise return false. In this context, downward path means a path that starts at some node and goes downward. And we are provided with some examples and also some constraints. The constraints talk about the number of nodes in the tree will be in the range of 1 to 2500, and the number of nodes in the list will be in the range of 1 to 100, and the node values lies between 1 and 100 for each node in the linked list and binary tree. To understand this question clearly, we'll take this example and explain it thoroughly so that we'll get a clear-cut idea how to solve this problem. So example 1 is provided with two input values. One input value is the linked list and another one is tree. So our motive is to find whether the tree contains that linked list or not, and finally return true or false. If the linked list is present in tree, then we have to return true, otherwise we have to return false. For that we'll do tree traversal. So we have three traversal techniques: pre-order, post-order, in-order. So for this question I'm going to use pre-order traversal technique. Actually we all know that pre-order traversal technique starts from root, left, right. So in the same order we'll do the traversal for this whole tree. So we have two steps. The first step is to find the start node of the linked list, whether the start node of the linked list is present in the tree or not. For that every time we do traversal for that node, we have to check whether the current node is equals to the start node of the linked list. For that first we'll start traversal from root. So if we start traversal from the root, first we'll check if the root value is equals to the start value of the linked list. If it is not equals, then we have to go further and do pre-order traversal. We already know that pre-order traversal starts from root, then we'll go to left child. So same here we'll go to left child, which is 4, and this node is present as the start node of the linked list. So here comes the step 2. So in step 2 we have to do a DFS travel for the current root value to check further nodes are continuously present downward in the linked list or not. So we'll start DFS travel for this node downward. We use pre-order technique to do the DFS traversal. So from here we'll go to left. If there is no further element left, it is null, then we'll return false. Again we'll check whether this node contains any right child or not. If it contains the right child, then we'll check that node is present in that linked list sequence or not. Yes, we have that node in our sequence. So further we'll check this node contains right value or left value. if it contains the left value, and we'll check that node value is present in linked list or not. If it is not present in our linked list, then we'll return false. Again we'll check for right. Here will not contain any right value, so we'll return false. So we'll go back to the head node and will return false for our DFS traversal. Then finally for this whole left subtree will get false as our answer, but we have right subtree, so from root we'll move to right subtree. So if we move to right subtree, the first step is to check whether that current node is the first node of linked list. Yes, here it is the first node of the linked list, so we'll do DFS traversal for this node to check whether other two nodes are also present downward or not. So for that I will do DFS traversal for node 4. So in DFS I have already told that we have to use pre-order technique, so we will move further for the left child. If that left child is present, then our have to check the condition whether this left child is present in our sequence. Yes, it is present in our sequence, so we have to do DFS traversal again for this step. Again we have to move further and see any left child is present or not. Yes, it is present, but this node is not equals to the node which is in our linked list sequence, so we have to return false here, and we'll again come to node 2. From here I have right child, so I'll move further and I'll check whether this value is present in our linked list sequence. Yes, it is present, so we'll move further and finally we'll get a null value. And if we'll move any further and we'll check, we get our linked list value as null. If we'll get our linked list value as null, then we have traversed all the linked list values. It states that we have all the linked list value present in our tree, so we'll return true value. So it will be written true for here, and again it will return true for here, and finally our total right subtree will return true value. So our final result is true. So our intuition is simple, like at every stage, if the current element is the start value of the linked list, then we are doing DFS search. So our time complexity for this problem is like we are traveling all n nodes, so n into, and whenever our current node value is equals to the start value, then we are doing m linked list traversals, so m length linked list traversal. So our time complexity is n into m, big O of n into m. So by this analysis we have got the clear-cut idea how this problem is solved. So we'll solve it in Java. So I have already told that first we have to check if the root value is equals to null or not. If it is null, then we have to return false, because if the root, if the tree is not present, then how can we check if the linked list is present in that or not? So we have to implement this. Then at second, we have to check if the root value is equals to head dot value. Like I have already told, if at any time we are traversing the whole tree, so if any node is equals to the start node of the linked list, then we have to do DFS traversal of head and root. If we have contained any linked list in it, then we have to return true, otherwise we'll move further and do pre-order traversal. So if you are doing pre-order traversal, we'll move left subtree first, then we'll move right subtree next. So root dot left will move left subtree, then at last we'll move right subtree, head comma root dot right. So here we have to implement the DFS method, public static boolean DFS of list node of head and tree node. So when we are doing DFS travel, we have to check if the head value equals to null or not. If the head value is equals to null, then we can be confirmed that the whole linked list is traversed and at last we got null value. So if we got null value, then we can say that the whole linked list is present in our tree. If the head value is not equals to null, then we have to check whether the root value is equals to null. If it is null, then we have to return false. For this, at any time we reach to the end of a tree in left or right subtree, will get a null value before traversing the whole linked list. At that time we'll return false, and further we'll check the root dot value is not equals to node dot value. If it is true, then we'll return false, else again we'll do DFS search for this. So we have in DFS search we have to move further. So I am here using head dot next for moving to another node, and I have to do node dot left as pre-order search, and here I have to do head dot next comma node dot right. So here is a simple brute force solution. Like I have already mentioned, the time complexity of this problem is n into m. Like we are traversing whole tree which is of n length. At every point we are searching for the head value of the linked list. If the head value of the linked list is the current node, then we'll do DFS search, which is of m length. So our time complexity is n into m. Here we have error, like okay, it is not root, we have to code it as node, then it is, oh again I have just mentioned root. Okay, now we'll try to submit it, and 97% faster.